this. Alright. Anne invests €5,000 in a fixed term paying 0.6% of compound interest per month. Does anybody know a quick way to increase something by 0.6 of a percentage? Let's make this easier. How do I increase something by 6%? Multiply by 1.06. Everybody cool with that? How would you increase something by 0.6 of a percentage? Thank you. 6% is 1.06. 0.6% is 1.006. Cool with that? Alright. So, in 1 month's time, what is the amount of money? Right, throw that into the calculator, you get 5,030. What about 2 months? How many times would you need to multiply by 1.006? Twice. And how much is it after 2 months? €5,060 and 18 cents. How many times would you need for 3 months? Anybody? Come on. 3 times. All you're doing is increasing it by 0.6% each time, and you get 50, 90, and 54. We all cool with that? Alrighty. Next thing. Write down a general formula for the amount of money Anne has saved. So what would be the amount of money? Yeah. I'd say amount of money equals what? 5,000 multiplied by 1.006 to the power of t, whatever letter you want to choose. Does it tell us in the question? It says t months, so don't use any other letter other than t. Everybody cool with that? Next thing. What's the minimum time? Oscar, which variable do you want when it says the minimum time? Do you want m or t? T. T is in what position? What do you think you're going to do? Both sides, yeah? You're going to have to do that. Alright. Double her money. What does double her money mean? The amount of money you have is going to be what? Huh? 10,000. You're going to double your money. So what do we change the m value to? Anybody? 10,000. That equals 5,000 by 1.006 to the power of t. First thing I'm going to do is go and get rid of that 5,000. How do I get rid of that 5,000? So we're going to get 10,000 divided by 5,000 is 2. Always do that. Because you always want to try and get rid of that, oh sorry, that's 3 zeros. Now, what do we do to both sides? Log. Any base you want, but usually we use log 10, don't we? Because we don't have to press any extra buttons, do we? If you use log 5 on both sides, the answer will still be the same. Okay, next step, what do we do with that t? Bring it to the front. So log 2 over t log 1.006. What happens to that log 1.006? Where does it go? Underneath, yeah. Sorry, not the t, the log. Now, the great thing about these questions is you can actually check your answer. Okay, I'll show you how to check your answer in a second. Somebody logged onto the calculator. What you get? I'm hoping you get 115.87. Just verify that for me. Now, here's a way of checking your answer. You ready for this? Get your table function out. Go to mode, only takes a second. You put in 5,000. You put 1.006 to the power of. Go with that. Now, you don't know how far to go initially, do you? Some of you might only go from 0 to 20. And you're like, okay, 0 to 20, what happens? Oh, at the he has 5,000. After 1 month, he has this much. 2 months, 3 months, 4 months, 5 months, 6 months, 7 months, 8 months, and etc. After 20 months, he only has this much. And you're like, it's going to be considerably bigger than 20, isn't it? You go back. Now, if I make the start 10 and I make the end 200, what's the minimum step I'm allowed to have? It's 20 spaces. You're allowed 20 saves. So divide your range by 20. 0 to 100 is 200 divided by 20. 10. I'll use 10. Okay? Otherwise, it says insufficient space. Keep going through it again. Stop when you get near 10,000. Somewhere between 110 and 100 ants. Does your answer fit that description? Happy days. Smile on your face. Takes a minute. You know you're correct. Move on. Cool? Alright. Let's drive on. Alright, guys. You guys give this one a go yourselves. Question 3. I think you'll find it reasonably handy. I'll come in behind you in a minute, okay? Now, for the first formula, replace t with 0, and you should be able to verify that's 15. So multiply by 10 by minus 0.02 times 0. Lob all that into the calculator. You're going to get 15 all day long. Okay? Oh, sorry, 45 all day long. Okay? Nextly, if the milk to be given to a baby when it's cooled is 35 degrees, find out how long it has to be left to cool to reach its temperature. Okay, that's not so bad. That's a T question, so we're going to have to find T. So the whole goal of the question is going to be to find the T value. And we know that it's 35. We know that the capital T value is 35, so the temperature is 35. My job is to get this value on its own. That's what I need to do. Step 1, bring the 15 over the other side and take it away, and you get 20. Now you have 30 multiplied by 10 by minus 0.02 t. Get that 30 and bring it down. So you have 20 divided by 30. And 20 divided by 30 is 2/3. Now we got very little left on this side. Our target is in the power position. And if it's in the power position, what do we need to do? Log. Any log of your choosing. So you're going to go for this log here. Go with that. Now, once we do that, what we're going to get is bring the power to the front, and we get minus 0.02 t log 10. And then we're going to get log 2/3 still. Bring that, bring the log 10 and the minus 0.02 t underneath. So we're going to get log 2/3 divided by minus 0.02 log 10. The answer has to be positive because it's time. You lob all of that into the calculator. I am hoping. Actually, log 10 is 1, isn't it? So it's down 1. So when you lob all that into the calculator, I'm hoping you get 8.8 minutes. Did anyone get 8.8? Alright. Any way of verifying our answer? How could you verify your answer, lads? 15 plus 30 multiplied by 10 to the power of minus 0.02, is it? Minus 0.02, and then alpha x. You with that? Start at 0, end at 20, step of 1. Check out what happens here. 45 keeps going down. What temperature did we want again? Wanted 35, didn't we? In between 8 and 9, it crosses the 35 region. Our answer is in that region. We're happy out. Keep going down for a second. Does it go down forever? Let's find out. Let's do a bigger range this time. Start at 0, end at 100. What's the step I'm allowed to use? Divide by 20. 5 would be a good step. And let's go all the way down. Let's see if there's anything that we can see happens at the end. Right. Let's go a bit higher. Let's go from 100 to 200, let's say. Let's go again. 100, 200, step of 5. Let's keep going. Oh, what's happening now? The gaps are getting smaller. It doesn't look like it's going to cross. It's not going to cross 15. This isn't going to happen. Now, why is it not going to happen is the question. We all know now that, just a bit of science for you. If I have a kettle at 100 degrees and room temperature is 23 degrees, that kettle will lose its temperature until it reaches 23. You got it? Can't go any lower than 23. If room temperature was 15, what happened to the temperature then? It'd drop all the way to 15. So if you have a bit of a science background, you'd know that anyway, okay? But how do you prove that mathematically? Okay, is the real question. So we go back to the start. I look at my formula here. Now, what I'm going to ask you guys is, I'm going to rewrite the formula like so. The formula is going to be rewritten like this. 50 plus 30. What have I done there? Can anybody tell me? Yeah, change the indice to the fraction. So as in 5 to the power minus 2 is the same as 1 over 5 squared. What happens to this number as t gets bigger? What happens to this number when t gets ridiculously big? When t is worth like a couple of million? The denominator becomes freakishly big, which means the fraction becomes freakishly small. So what you say, as t approaches infinity, 30 over 10 to the power minus 0.02t is roughly equal to 0. This means your maximum temperature is 15. We knew that from evidence from the table function, didn't we? So you would have had a good chance of doing it anyway. That's how you explain it though. Alright, let's keep going. We're doing well. Good 17 minutes left. We're comfortable today. Alright. Yeah, go on. Let's try this one. Question 6. Pretty similar to question 1. What we're going to do here, guys, is the following. Consumer price CPI measures the cost of goods and services on a yearly basis. Assuming the commodity was valued at 100 in 2000, show that the CPI has been rising exponentially at 4.5% since that year. Find the value of commodity in 2 years after the year 2000. Alright, so CPI or cost is going to be 100 euro multiplied by, how do you increase something by 4.5%? 1 by 0.45 to the power of t. Lob that into your good old table function. The savior of your leaving cert. It really is. And then go from 0 to, let's say, 20, step of 1. And what you see here is every year it increases it by 4.5%. Is that okay? In whatever, 7 years time, you're going to be at 136. Right? That's handy enough. The predicted cost of commodity in 2010. 2010 would be, yeah, you can just lob it in here. Okay. And what would you get? Anybody got it? Huh? Yeah, 155 euro and 30 cents. Okay. Now, the reason for that is, year 10, x equals 10. It's actually 11 on mine because I included 0. So year 10 is 155 euro 30 cents. Now, oddly enough, there's a little trick here. Here's your trick. What's 5 years beforehand? If t equals 0 is 2000 and t equals 1 is 2001, what's 1995? Exactly. Minus 5 is 2000 and 1995 is t equals minus 5. So log in minus 5 and see if it gives us a reasonable answer. But you're just decreasing the amount by 4.5% each year. So in this case, it does make sense. So you're going to do 100 by 1.045 to the power of minus 5. And what do we get? Huh? Yep. €80 and 25 cents. I actually believe I was looking through them last night, and I'm a big fan of. Oh, we gotta do that one. Sorry, 8. Now, guys, there's something very important here, and just in case this comes up in the test tomorrow, don't do anything for a minute. Right, don't do anything. See when you see E in the answer, see E. Okay. What's log 10 base 10? 1. What's log E base E? 1. Right? There's a special button for that. It's called ln. So ln E would also be 1. Everybody cool with that? Does everybody see the ln button? ln is a log. It's basically log base E. So it obeys all your log rules. You get what I'm saying? So really quickly, what's ln 2 to the power of x? What can we do to the x? It obeys all log rules. So what can we do with the x? X ln 2. Does that make sense? What's ln 3 plus ln 5? ln 15. Everybody cool with that? It behaves like a log. It does all the log rules. Okay? Now, in this case, we'll just use ln instead of log to do the answer, just to see what happens. Is that okay? Just part of this practice, right? So, do you want to give it a go, or will I do it for you? Yes. I think you can do both. Just in case. See, usually when you have an E, you'll use ln because the ln will cancel the E. Okay? I still think it'll work out with log 10 though. But just in case a particular question comes up, so you haven't seen the test yet. So I just want to make sure you're flexible with your approach. Okay, so let's do this really quickly, okay? Find the value of M, O, and K. No bother. So M equals MO e to the power minus KT. M equals 10G when T equals 0. So what does that mean? 10G, which is 10 times gravity, equals MO. And what's the power of 0? T is going to be 0, isn't it? So that'll be e to the power of 0. What's anything to the power of 0? 1. So this means MO equals 10G. Is that alright? What's the second piece of data we have then? The formula will now change to M equals, we know what MO is, don't we? MO is 10G. And now we have e to the power of KT. Is that alright with you guys? Now, what does it say I can replace M with? Replace M with 5G. And what do I have to replace T with? 140. So what do I have up here? Excellent. Right. Normal logs will work as well. Just let you know, log will work as well. It will work. But I just want you to make you aware of ln as well. Okay? Now, what happens to the 5G and the 10G? Bring the 10G underneath, what happens? What's 5G over 10G? Half. Now, you can log both sides, or in my case, I prefer to ln them because I'm working with E. Go with that? What's the normal rule that happens with logs? What happens to the 140? Yeah. What is ln E? What is log E base E? So what can I do with the ln E? Just disappears, doesn't it? And what it does is it makes for a tidier answer. And then we have ln half. And then what's k on its own then? ln a half over 100 and minus 140. What is ln a half over minus 140? You should all do it in the calculator just to practice it this one time. ln 0.5 divided by minus 140. We get a k value of that. Yeah, I literally said that. It is the correct answer. How many zeros are there? Does it say any information on how to round it off? Nope. So it's a lot of decimals. So what we're going to write down? We can write down 4.95 by 10 to the power minus 3, or divide by 10 3 times. Once, twice, 3 times. Yep. Everybody cool with that? Good? Yes. No. It means what's the mass at the beginning at 0 seconds? The 0 does nothing. It's a subscript. Yeah, it's just a variable. Alright. After how many days will there be 2 grams of polonium left? I want you guys to do that now. Just use your equation and put in, actually guys, you'd be grand. You just do it by logs, don't you? But we won't have time. I just want to do something else for a second. What you do here is you replace that with 2G. You replace M0 with, anybody? 10G. 10G looks like log, doesn't it? That's annoying. Alright, 10G looked a lot like log, so just don't confuse that in the exam. What can I replace K with? Point, just 1 sec. 00495 T. Everybody cool with that? Does everybody know how to finish off that question? What do you do to both sides? Bring down the 10G, then what do you do after that? You can ln or log both sides, and we do what we've always done. What questions did we do? We did 1, 3, 4, 6, 8, which isn't a bad haul.